Hello students, welcome back to our channel Diksha Karnataka. So we have already done midterm revision for physical chemistry, inorganic chemistry and organic chemistry, but I got many requests from you people regarding aldehydes, ketones and carboxylic acid. So I didn't do this chapter because I think this chapter was not there, but after seeing your comments I came to know some of you are having aldehydes, ketones and carboxylic acid as well in your portion for your midterm examination. So yes, in today's video we are going to cover all the most expected questions that can be expected from in your midterm examination from this particular chapter. Okay, so I'll be discussing, so these questions I have taken from the blueprints and I have analyzed last 10 to 15 years of question papers and have picked up the most repeated questions. So when you go to the exam, make sure that you revise these questions definitely. Okay, so now let us move towards the question pattern. So if you see, there are total 12 marks from this chapter. Okay, this chapter carries weightage of 12 marks, out of which there will be 2 questions in the long answer, 5 marker questions, and this will carry 10 marks, right? 2 plus, like 5 plus 5, 10 marks, and 2 MCQs will be given. That is 1 marker question. It can be either your fill in the blanks or MCQs. You will get 2 MCQs or 1 fill in the blanks and 2 5 marker question. Now students, see, this chapter I know is very lengthy chapter and a lot of name reactions, lot of reactions are there in this chapter, but because this chapter has 5 marker questions, so it is very easy to score here. Okay, may not be you are able to score like 5 out of 5, but the questions will be of this type, generally 3 plus 2. Okay, so this 3 marker something, 3 questions will be there, something, some most predictable questions we can practice, and definitely we can get this 3 marks, or you can get this 2 marks or somewhere in between. So there is very less probability that you will be getting 0 out of 5 in this particular long answer questions, because these 5 marker questions are very predictable and are often asked from those like name reactions, some mechanisms. So these questions are very predictable, so definitely you can score. Not 5, may not be you can go like, because it has lot of reactions and all, so you may skip something, but you will not end up at 0 out of 5. That much I can assure you if you like do the major topics of this particular chapter. Okay, so now let us move towards the questions. Okay, so first we'll be discussing some 10 to 15 MCQs, then we will go for some 10 5 marker questions we'll discuss, so that you will have a revision of this. Okay, now I want you to sit with a notebook and a pen and revise these questions with me, note down the answers, write, you should know how to write the answer, how to present the answer. Okay, so yes, now let's get started with the first question. So this MCQ I think I have taken from your blueprint. So among the following alkyl benzenes, which one will not give the benzoic acid on oxidation with KMnO4 solution? So if you remember, what is this reaction? Any R group is present here. Okay, if you treat it with KMnO4, okay, this gets converted to COOH. Okay, but you should remember that this R group should have one H, should have acidic hydrogen. Okay, now if you see these compounds, the options that is given here, what is CH3? So here there is a H is present, so definitely this will get converted to carboxylic acid, but the question is which one will not give, means which will not convert. Okay, next if you see here, this carbon, okay, this carbon is not having any acidic H. Okay, next means the carbon which is attached to the benzene ring should have an acidic H. What is the condition? Carbon attached to benzene ring, okay, attached to benzene ring should have a H. Okay, now this carbon is attached to benzene ring and it is having 3 hydrogen. Now if you see here, this carbon which is attached to the benzene ring doesn't have any hydrogen, so that is why this cannot be oxidized, and the correct answer for this question will be option number B here. Clear? Next here if you see this carbon, he is having 1 hydrogen, so it will be also oxidized, and this carbon has 2 hydrogen, so that is also will be oxidized. Okay, next question, an organic compound with the molecular formula C9H10O, okay, forms 2,4-DNP derivative, reduces Tollens reagent and undergoes Cannizzaro reaction. On vigorous oxidation, it gives 1,2-benzene dicarboxylic acid. The organic compound is. Okay. So now when you see that it reduces tolerance reagent, so immediately what we can think that it has to be an aldehyde group, right? Okay. Next, 2,4-DNP reaction is happening. 2,4-DNP reaction is happening. What it indicates? It has to be a carbonyl group, right? Next, undergoes Cannizzaro reaction. What does this signifies? Cannizzaro reaction means it should not have any alpha hydrogen. Okay. Next, if you see, it gives 1,2-benzene dicarboxylic acid, means the two substituents should be adjacent to each other, right? They should be next one and the next carbon should have some substituent. Now, if you see 3-ethyl benzaldehyde, let us see this structure. 3-ethyl benzaldehyde. This is 3-ethyl benzaldehyde. Now, if this one gets oxidized, we will get carboxylic acid. So, this is satisfying all the conditions. See, it forms 2,4-DNP because this is carbonyl group, it will react. Reduces tolerance reagent, yes, this is an aldehyde group. Undergoes Cannizzaro reaction, no alpha hydrogen, that is correct. But if you oxidize it, we will get 1,3-dicarboxylic acid, not 1,2. So, this option is incorrect. Next, 2-ethyl benzaldehyde. If this benzaldehyde is present here, 2-ethyl benzaldehyde, okay, one second, yeah, if this is present 2-ethyl benzaldehyde, then definitely I think this one will give you 1,2-benzene dicarboxylic acid on the, oxidation. So, correct answer for this question will be option number B. 4-ethyl will give you 1,4, and what about 2,3-dimethyl benzaldehyde? So, let us see this one. So, 2,3-dimethyl will give you 1,2,3-tricarboxylic acid. So, that is why this is also not the answer. Next, which of the following compounds is most reactive towards nucleophilic addition reaction? So, first of all, here you should know that aldehydes are more reactive than ketones. Okay, aldehydes are more reactive than ketones, so ketones are less reactive. So, if you see this is a ketone, this is a ketone, we can eliminate these two options. Okay, directly we can eliminate option number B and D. Now, if you see out of these two, what is the next factor? What should be the factor that affects the reactivity? The electrophilicity of carbonyl carbon. Right, means what? This carbon which is having this carbon should be electrophilic in nature. Okay. Now, what happens if this benzene ring is present? Due to resonance, it donates electron here, and the electrophilicity of this carbon decreases. Okay, electrophilicity of this carbon decreases. But here what happens? It donates, no doubt, but it donates by plus I effect, which is not a very strong effect as compared to plus R effect. Right. So, that is why this is more electrophilic, this carbon is more electrophilic. Okay. So, it will be more prone to nucleophilic reactions. So, correct answer for this question will be option number A. Okay. Next, the correct order of increasing acidic strength. Okay, so acidic strength, you have alcohols and acetic acids. Always carboxylic acids are more acidic undoubtedly. Okay, so definitely acetic acid or chloroacetic acid has to be at the starting, and that is there in all options except ethanol. So we can eliminate this option. Okay, now if you see acetic acid, acidity, okay, acidity is proportional or is favored by electron withdrawing group, increases the acidity. Okay. Now, if you see, we have chloroacetic acid. Chlorine group has what? Minus I effect. So, it is an electron withdrawing group. It will increase the acidity, right? So, chloroacetic acid will be more acidic. So, like suppose you have like this CH3 COOH. This is acetic acid and this is chloroacetic acid, right? So, what happens? This chlorine is electron withdrawing group. Okay. It stabilizes the conjugate base and hence increases the acidity. So, definitely chloroacetic acid has to be the highest acidic. So, we can keep all these three options. After chloroacetic acid, there will be acetic acid, right? So, we can eliminate this option because here it is acetic acid, here also it is acetic acid. Delete these two options. So, first chloroacetic acid, then acetic acid, then phenol, then ethanol. Okay, correct answer is option number C here. Next, compound PHOCOPH. So you have PHOCO and pH. So this is which group? This is an ester group, right? How can we synthesize esters? Esters can be produced by the reaction of alcohols with carboxylic acid, or with acyl chlorides, or with acid anhydrides. Okay, all these three reactions will give you esters. Okay, so can be prepared by the reaction of. So definitely we need one phenol group, and we can have either benzoic acid or benzyl chloride or this one, right? So let us see. First, phenol is there, phenol is there, phenol is there, phenol is there in all the options. Okay, benzoic acid in the presence of NaOH. No, this reaction, the reaction of an alcohol with an acid takes place in the acidic medium, and this takes place in the basic medium or in the presence of a base. Okay, this requires the presence of a base. So this could have reacted if it is a acidic medium, but here because it is a base, we can eliminate this option. Okay, next, phenol and benzoyl chloride in the presence of pyridine, and pyridine is a very good base. So yes, the correct answer is option number B here. Okay, next question, the reagent which does not react with both acetone and benzaldehyde. So if you know Felling's reagent, okay, Felling's reagent gives test only for aliphatic aldehydes. Okay, it reacts with aliphatic aldehydes and does not react with aromatic aldehydes. Okay, so benzaldehyde, which is given in the question, is a aromatic aldehyde, so that will not react with acetone because it is a ketone, and benzaldehyde because it is an aromatic aldehyde. Okay, so correct answer is option number C here. Next, Cannizzaro reaction is not given by. So what's the condition for Cannizzaro reaction? Absence of alpha hydrogen. Okay, if there is no alpha hydrogen, then we can get products in the Cannizzaro reaction. So now if you see here, this particular first compound, right? Here if you see, this is the alpha carbon. It has no alpha hydrogen because here CH3, here CH2, CH2, no alpha hydrogen. So this one will show Cannizzaro reaction. Next, if you see here, this is the alpha carbon, this is alpha carbon, here also no hydrogen, so this one will also show Cannizzaro reaction. Now if you see this one, here also no alpha carbon, no alpha hydrogen, this one will also show Cannizzaro reaction. Question is asking not given by, which will not react. So if you see this compound is having alpha hydrogen, right? Because it is having alpha hydrogen, it won't react Cannizzaro reaction. Correct answer for this question will be option number D here. Okay, so let me erase these ticks, otherwise we'll get confused. Okay, correct answer will be option number D. Now next question, okay, this is a reaction based question, H2SO4, HgSO4, oxymercuration and demercuration, right? So what will happen? We'll get a enol in the first case where H and OH are added following Markovnikov's rule. So what will happen? If you see, this carbon is having less number of hydrogen, so OH will attach here and H will attach here, right? So what I'll get? A will be CH3 COH double bond CH2. Okay, so this is A. Okay, after that what happens? Tautomerization takes place and we get CH3 C double bond O and CH3. Okay, so this is B, or this is the product is given. So this process is what? Tautomerization. Okay, so now what is the so obviously tautomerization is there in this option and in this option. We can eliminate this two option. Now what is the name of this compound? So we can name it like 1, 2, 3, prop 1En2OL, right? Prop 1En2OL. So correct answer is option number D here. Okay, next question, compounds A and C in the following reaction are. Okay, we need to again predict all this. So CH3CHO, CH3MgBr, addition of Grignard reagent, very easy step this one. See, CH3 C double bond OH and you have CH3MgBr. Okay, plus minus, this one will attack here, this one will go, O minus will take MgBr, and after hydrolysis OMgBr gets converted to OH. So what I'll get? CH3 C here OH then I'll get CH3. Okay, now H2SO4 and heating, that is what, dehydration. So what will be B? I'll be getting propene here, CH3 CH double bond CH2, right? This is B. Now after that what happens? Again addition, hydroboration and oxidation, right? This adds this will add OH and H following anti-Markovnikov's rule, right? So what I'll get? CH3 CH2 CH2 OH. Okay, so this is your C. Now if you see what is the relation between B and C, relation between A and C. In A, OH is present on the second carbon, and in C, OH is present on the third carbon, right? Sorry, first carbon. So the same functional group on different positions are called as positional isomers. So correct answer is option number B here. Next, which is the most suitable reagent for the following conversion? So what is the conversion? CH3. So you see here, this CH3 group, okay, this CH3 group is converted to OH, and there is a, like, this compound is having less number of carbons, like one less carbon is present. So this happens, and you can see this group is your what? Acyl group, and this acyl group shows iodoform reaction, right? So the correct answer for this question, I think all of you would have guessed by now, I2 with presence of NaOH, that is option number C. Okay. Next question, which of the following compounds will give butanone on oxidation with alkaline KMnO4? Okay, we need to oxidize with alkaline KMnO4, okay, and the product that is required here is butanone, that is CH3 C double bond O CH2 CH3. Okay, now the question here is, we need okay, butanone is there. Now this is what? This is a very strong oxidizing agent, right? Now what are the options you see? Butane 1-OL and butane 2-OL. What is butane 1-OL? This is primary alcohol and this is secondary alcohol, right? Primary alcohol under strong oxidation conditions give rise to acids, right? If you remember, primary alcohols under strong oxidation, if you have primary alcohol under strong oxidation will give you acids, but we don't want acid, right? We want ketones, so we need to take secondary alcohols. Okay, so butane 2-OL will be the correct answer, so option number B. Okay, now let us see the next question. In Clemmensen reduction, carbonyl compound is treated with, so we have zinc, amalgam and HCl, so option number A. Okay, next, as the size of the aldehyde molecule increases, the order becomes, so as the number of carbons size increases, it becomes more fragment. Okay, so correct answer here will be option number B. Next, the reagent useful for separation and purification of aldehydes is, so this is also a question from blueprint. So when you treat aldehydes and ketones with sodium hydrogen sulfide, okay, what we get? We get white crystals. Okay, and we can easily separate and purify them. So correct answer for this question will be option number B. Okay, next question, match the following is there. So yeah, name reactions and their reagents are there. Gatterman-Koch reaction, COHCl, so A has to be 3. So A has to be 3, so we can eliminate option number, first option we can eliminate. Next, FN reduction, SNHCl, so B has to be 1. So B has to be 1, so we can eliminate this option, right? Next, Rosenmond reaction, H2 palladium, so C has to 4. This is wrong, C4D2, correct answer is option number B here. Okay. Now that's all in the VSA 1 marker question. Now we will move towards the 5 marker question, where it is really very easy to score if you focus on certain important topics. Okay, let us see the first question here. Between methanol and ethanol, which would undergo aldol condensation? Write the chemical reaction involved in it. So the first thing that you must revise from this topic is your aldol condensation. Very, very important reaction and must do topic. Okay, please revise this. I'll be telling you the topics that you should revise. Keep a note of this and keep revising these particular chapters. Okay, these particular topics. So first reaction is aldol condensation that you need to revise. Now let us see what is the answer for this question. See, between methanol and ethanol, which would show aldol condensation? So if you know, you have to write the answer like this. You need not write anything, like no need to define anything. Question is simply asked which one will react. The answer is ethanol, because what? In aldol condensation, what is the condition? It should have alpha hydrogen, right? So you can write answer like this, A. Okay, between methanol and, so I'll write the answer here. Okay, one second. Yeah, so now we can write like this, between, okay, methanol and ethanol. Okay, ethanol will show aldol condensation. Okay, aldol condensation because of alpha hydrogen, or because it has alpha hydrogen. Okay, that is the first thing. Second thing, you have to write the chemical reaction involved in it. You have to write the chemical reaction as well. So if you write ethanol, so H2COH. Okay, so in presence of what happens, dilute OH or OH minus, we get a what we say, CH3, CH2 minus, C double bond OH, right? Then another molecule of this one is taken, CH3, CH2, one second, yeah, CH3, CH2, COH. Now what happens? This one attacks on this carbon and this bond shifts here. Okay, so we will get here. So you have to be very, very careful while writing the products. Okay, so we have here CH3. Okay, then CH2, I have written these two, then I have this C, on that OH is present and then H is present, right? And this part is attached to this particular carbon. So I will write here this one CH2 here. Okay, next we have one side CH3 and then we have COH. Okay, clear? Done this part. We have written as it is. Now what will happen? Now there is a we can have dehydration, right? So you have to write the product of dehydration. So there can be either this one, or we can have a compound here, right? So here there will be resonance, so it will be more stable. So we will get a product like this. Okay, so let me write it clearly. We will get like this, CH3, CH2, CH, then I have double bond, then CH, CH3, okay, and COH. Okay, one second, yeah, COH. Okay, so you have to get more substituted alkene, so that will be the major product formed here. Okay, so that is done. Now the question is, although, so please copy this answer, okay, if you are writing. So just you need to write the mechanism. So here when you are doing condensation, okay, so there you need to write minus H2O, right, or heat, you have to provide heat. Okay, where we have done this one, that is this one, to provide heat to get double bond. Okay, so here we can write the product back how it was. Okay, here there is OH. Okay, then if you provide heat, we'll get this particular answer. Now the question is, although phenoxide ion has a greater number of resonating structures than carboxylate ion, carboxylic acid is a stronger acid than phenol. Why? Okay, so I'll show you the answer here. See, for phenoxide ion has more number of resonating structures, but in phenoxide ion the negative charge comes on the less electronegative atom, that is carbon, whereas in carboxylate ion the negative charge comes only on the oxygen, which is a very electronegative atom. Okay, so this is how you need to write this answer. First one clear. Now for second one I'll be telling you, so I'm erasing this one. Okay, now see, for second one what you need to do, you have to first draw the resonating structures. Okay, carboxylate ion, so for example you have CH3 C double bond O, O minus, and its resonating structure will be like this, right? CH3 CO minus double bond O. Here you have to write resonating structures of carboxylate ion. Okay. Next, what you can do, resonating structures of phenoxide ion. Okay, so O minus, this bond will come here, this one will come here. So we will get a structure like this now. This one and this one, then this one and this one. So we will get a structure here, one more, that this one double bond, this one and this one, next this one and this one. So I'll get a resonating structure like this. Okay, so this one and this one and then this one. Okay, then again it will be there, this one will come back. So I'll get here one more resonating structure like this. This is like this. Okay, so you see now in the resonating structures of phenoxide ion, negative charge is coming on carbon, which is less electronegative, and that is why this is unstable. And here one you can see that the resonating structures of carboxylate ions are equivalent. Okay, both the resonating structures are same, but here it is not same. So that are the two reasons why phenoxide ion is less stable than carboxylate ion. Okay, so you can see here the conjugate base of carboxylic acid, that is this carboxylate ion, a carboxylate ion is stabilized by two equivalent so you need to mention these points. What are the two important points? It has two equivalent resonating structures in which the negative charge is at the more electronegative oxygen atom. Okay, first of all, it is having two equivalent resonating structures, and second point is the negative charge is present on the more electronegative atom, that is oxygen. That is why that is more stable. Now if you compare it with the phenoxide ion, it has non-equivalent resonating structures and the negative charge is at the less electronegative carbon atom. So you can see the negative charge is coming on the carbon atom, right? Therefore, resonance in phenoxide ion is not like you can write is not as important as in carboxylate ion, or you can write therefore carboxylate ion is more stable and hence more acidic. Okay, so understood how the mark distribution is there? See, here it is 2 marks. Okay, to write which one will react and then writing the product, and here it will be 3 mark if you draw these two resonating structures 1 mark and write down this point 1 mark. Clear? Next question. Give the chemical equation for the conversion of propane nitriles into corresponding ketones using phenyl magnesium bromide. Okay, write the IUPAC name of the product. Okay, so let us first do this one. So you need to do what? Propane nitriles means CH3 CH2 C triple bond N. Okay, propane nitriles reacting with phenyl magnesium bromide. So you have reaction with phenyl magnesium bromide. Okay, now what will happen? Minus plus you can easily find out. Now what will happen? We'll just add these things. So what will happen? This is minus, right? This one will attack here and this one will attack here. So what will I get? CH3 CH2 C, then I have this phenyl group attached here, right? And then we have double bond N MgBr. Okay, next what you can do, just do hydrolysis. Okay, so what we will get? CH3 CH2 C, then I have phenyl, and here it will come double bond O. Okay, so we can write it like this. One second, let us write like this, C double bond O phenyl group. Okay, now you need to write the IUPAC name for this one. So on the first carbon this phenyl group is attached, so you can write down 1 phenyl, okay, propane ONE. Okay, 1 phenyl propanol. Okay, so clear. Now coming to next part, explain the HVZ reaction with an example. Okay, now if you see HVZ reaction, so carboxylic acid having an alpha hydrogen are halogenated at alpha position on treatment with chlorine or bromine in the presence of small amount of red phosphorus to give a halocarboxylic acid. Okay, so what is this? Is the definition. So what is there? Carboxylic acid having alpha hydrogen at alpha position on treatment with chlorine or bromine in the presence of small amount of red phosphorus to give alpha halocarboxylic acid. So what are the key things that you need to remember here? See how to write this definition. It looks little complex, right? I'll tell you how you can write it. Simplify. See, carboxylic acids having an alpha hydrogen. Okay, carboxylic acids having alpha hydrogen. When carboxylic acids having alpha hydrogen on treatment, you can leave this part. Okay, this part you can leave. Carboxylic acid having alpha hydrogen on treatment with chlorine or bromine in the presence of small amount of red phosphorus. So you can just write down in the presence of red phosphorus gives us or give alpha halocarboxylic acid. This term is very important to use, that is alpha halocarboxylic acid. This reaction is called as HVZ reaction. Now let us remember this one. Carboxylic acids having alpha hydrogen on reacting with chlorine or bromine in presence of red phosphorus gives us alpha halocarboxylic acid, right? Gives alpha halocarboxylic acid. This is HVZ reaction. Now you need to write the reaction also. So with example, so we will write like this, CH2. Okay, just show like this the alpha carbon. Okay, here you mark this one, mark it as alpha hydrogen. Okay, now if you take it with Cl2 red phosphorus, what will happen? This H will get converted to Cl, right? So I'll get product like this. Okay, this is the example. Clear? So you see here we will get 2 marks for the mechanism, 1 mark for the IUPAC name, 3 marks, and here 1 mark for the definition. This is 1 mark and example 1 mark, total 5 marks. Clear? So what is the next important thing that you need to study? HVZ reaction, very important question. Okay, so 1 second. Okay, now we'll go to the next question. Write the mechanism of addition of HCN to carbonyl compound in the presence of a base. Okay, so first answer for this we need to write the mechanism, right? So first, in the presence of base. So if we have HCN in presence of any base, what will happen? We will get Cn minus plus water. Okay, this is the first step. Now any carbonyl compound is there, so they have mentioned just carbonyl compound, so you need to write like this. So what will happen? This Cn minus can now attack on this one and this bond will shift here. So we will get like this, O minus and Cn. So here this is what? This is tetrahedral structure. Okay, after that just provide H plus to get OH and Cn. What is the name of this compound? Cyanohydrine. Okay, so this is the mechanism done. Next, you can see here this will be 1 mark, writing this one will be 1 mark, and writing this product will be 1 mark, 3 mark we got. Now aromatic carboxylic acid does not undergo Friedel-Crafts reaction, give reasons. So here what is the first reason? 1 second. Okay, now here what is the first reason we have? The first reason is COH group, okay, is a electron withdrawing group, okay, and it deactivates the ring, and it deactivates the ring, okay, deactivates the ring for substitute for electrophilic substitution. Okay, now second thing, COOH group reacts with AlCl3 and reacts with AlCl. That is the another reason. Okay, so here you write the mechanism, 3 marks, here you write this is 2 marks. Okay, this is the same question. Next we'll go to question number 4. How do you prepare phthalimide from aromatic dicarboxylic acid? So preparation of phthalimide from aromatic dicarboxylic acid. So let us first do this reaction. Okay, so if you want to prepare aromatic dicarboxylic acid, okay, we have this one. Now here first you treat it with ammonia. So what I will get, eraser it, wait 1 second, we'll get dicarboxylic acid. So what is happening here? See, this acts as a base, this acts as an acid. So they will release H plus, this will accept H plus, and we get a salt here. So like a compound like this is formed. Okay, NH O minus NH4 plus, and here also O minus NH4 plus. Now what happens from here and from here, water is released. Okay, so what happens, you just need to do heating. So we will get like this a compound. Now see, C double bond O. Okay, now here what happens, this O and this 2H is released. So what is left here, NH2, and same here it is NH2. Okay, now again if we heat, what happens, ammonia is released and we get phthalimide. Okay, so 1 second, I'll write and then I'll move so that you can sit. 1 second. Okay, let me write on the other side. So what will happen, this one is formed. After this reacts again. If you heat it, we get here like this, C double bond O NH, C double bond O NH minus NH3. Okay, so this is the product formed and this is called as your phthalimide. Okay, done. Now if you see next one, so this whole reaction give equation, this carries your 3 marks. Okay, so you can see we have 1, 2 and 3 steps. So 3 steps, 3 marks. So you need to understand how is the mark distribution for a particular question. In the same way you need to write the answer. Now you see A and B, you need to write 2 products and that will give you 2 marks. So definitely this is hot concentrated acid. What is this name reaction? Cannizzaro reaction, right? So one will be oxidized product, one will be reduced product. So what will I get here? 1 second. Products will be, we'll get one like this where I will have COO minus Na plus and the other product will be CH2OH. Okay, oxidized and reduced product. A and B, anything you can give. Clear? Now let us move towards the next question. Write the reactions involved in the conversion of toluene to meta-nitrobenzoic acid. Okay, so you need to write toluene to meta-nitrobenzoic acid. Okay, so let us first try this one, 3 plus 2. So you can give, first one is 3 plus 2. So toluene is there. Okay, toluene to meta-nitrobenzoic acid. Okay, so first one A, toluene we have, okay, and then to meta-nitrobenzoic acid. Okay, meta-nitrobenzoic acid. So we need to do this. Okay, so now see answer. See, first what happens, either you can first add nitro group and then can oxidize CH3 to COH, that is one possibility, or first we will oxidize CH3 to COH and then convert it into nitro group. Okay, that is the thing. Now what happens here, the CH3 group is an ortho-para directing group. So if you do first nitration, then NO2 group will not come in the meta position. NO2 group will go to ortho and para position. So the first step should be, but COH group is a meta directing group, so that will direct NO2 to meta position. So the first step should be oxidation of CH3 to COOH. So how we can do is, first we will do CH3. What I am saying, let me just tell you, if I do nitration here, okay, if I do nitration like this, for nitration what is required? Concentrated HNO3 and concentrated H2SO4. If I do this oxidation, what will I get? This one I will get, right? Now, sorry, 1 second, yeah, we will get what? Nitro group will be substituted here. So we will get product like this. Okay, we will never get meta product. So that is why this step is wrong. Doing first nitration is wrong. So what we should do? First we need to convert CH3 to COOH. So what is the reagent for that? For doing this we need KMnO4. Okay, strong oxidizing agent. This will convert this one to COOH. Now this is because electron withdrawing group. Now if I do nitration, concentrated HNO3 and concentrated H2SO4. So what will I get here? I will get here COOH is present and at the meta position NO2 group will be attached. Okay, so that is the answer. So this one will give you 3 marks. Next question, the pKa values of acetic acid, benzoic acid and trifluoroacetic acid are given. Okay, so you have acetic acid, okay, then you have benzoic acid, okay, then you have trifluoroacetic acid. Okay, fine. Now and the pKa values are given. Arrange them in the increasing order of acidic strength. Justify the arrangement. Okay, so if you see, acetic acid is having how much? 4.76. Okay, now benzoic acid is having 4.19. Okay, and trifluoroacetic acid is having 0.23. Okay, so what will be the increasing order of their acidic strength? So this is very easy. See, this is what given, this is given your pKa values, right? And pKa values inversely proportional to acidic strength. Okay, means lesser pKa value means higher acidic and higher pKa value means less acidic. So which is the this is the highest pKa value, that means this acetic acid is least acidic. Okay, and you see here, this is the 0.23, this is the least pKa value, that means this is the highest acidic. Okay, now we need to arrange them in the increasing order. So what will be the increasing order? First is acetic acid, okay, then we have benzoic acid, okay, and then we have trifluoroacetic acid. So this is the first thing done. Now justify the arrangement. So for justification you can write down, because it has trifluoro group CF3, it is a very good electron withdrawing group and it stabilizes the conjugate base, so that is having the highest acidic. Next, benzoic acid, it is stable because of resonance, and here there is no electron withdrawing group, so that is the least acidic compound. Okay, fine. Next question, an organic compound X with molecular formula C8H8O gives orange red precipitate with 2,4-DNP reagent. Means what does it first thing gives you? See, you have a compound X, okay, C8H8 and O. Now this one is giving you with 2,4-DNP, what is the product formed? Orange precipitate. Now what does this signify? This indicates that X is what? Is a carbonyl group. Okay, means either one aldehyde or a ketone group. Okay, next, and gives yellow precipitate on heating with iodine in the presence of sodium hydroxide. So if you treat it with iodine in presence of sodium hydroxide, what we get? We get yellow precipitate, right? So what is this indicating? This says that there must be one CH3CO group attached somewhere. Okay, next, it neither reduces Tollens reagent nor it discolorizes the bromine water. It is not reducing Tollens reagent. That means what? This carbonyl group is nothing but, we are now confirmed that it is a ketone group, because ketone group does not react with Tollens reagent, right? So we know that this is a ketone group. Now on oxidation with chromic acid gives a carboxylic acid Y. So if you treat it with chromic acid, okay, we give Y, right? That is what is given. On oxidation with chromic acid, X gives a carboxylic acid Y having molecular formula of C7H6O2. So this molecular formula is C7H6O2. Okay, fine. Next we see, identify the compounds X and Y and write all the reactions involved. Okay, so first of all we need to think here that it is a ketone group, okay, and it is giving you yellow precipitate, means COCH3 group is there, and whenever there is carbon more than 6, always there is a high chance that it has to be a benzene ring is definitely involved. So I think now I would have already found out what is X. X has to be what? Benzene ring is present, and I also know that this group is present, right? This is your X. Now if it reacts with 2,4-DNP, we have to write all the reactions, right, with 2,4-DNP. So what is the structure of 2,4-DNP? If you remember, we have NH2, then we have NH, and here we have 2-position nitro group and 4-position nitro group, right? That is 2,4-DNP. Now if I react with this one, I'll get this compound like this, okay, CH3, then I have double bond, this O and this H2 will go, right? Then I have N, then I have NH, and then we have this one, and here we have 2,4-DNP. Okay, that is the first reaction. Next, what is giving with, if X is reacting with I2NaOH, okay, that is your iodoform reaction. So what will happen, this bond will break here and we'll get a salt here, right? So I'll get like this, C double bond O, O minus, Na plus, and then this one will get converted to CHI3. Okay, next, it neither reduces tolerance range, so this is no reaction, on reaction with chromic acid. So if it reacts with chromic acid, that is H2CrO4, chromic acid, it reacts, we will get what? We'll get this one as a carboxylic acid, right? C7H6O2. So we have 6, then here 6, 5, 1, 2, 3, 4, 5 and 6 and O2. Okay, that is the product we will get. Clear all the reactions, X and Y. So this is your Y. Y is what? Benzoic acid. Okay, done. Okay, now let us move towards the next question. Explain Wolff-Kissner reduction with equation. So first of all, we'll go for the first question, Wolff-Kissner reduction. So you can just write down carbonyl compounds are reduced to alkanes, okay, in presence of what? In presence of hydrogen, that is NH2 and alkylethylene. You can write NH2 KOH. Okay, this reaction is called as Wolff-Kissner reduction. Now if you write with an equation, so you can just example CH3, C double bond O, CH3, and if you react with NH2, okay, and KOH, so you will get a compound like this, CH3, CH2, CH3. Okay, next, how is benzaldehyde prepared by reaction? Prepared by Rosenmond reaction. So you need to take what? Benzoyl chloride here, okay, and you need to also write the reaction here, like write the statement here, benzyl chloride on reacting with H2 palladium barium sulfate gives benzaldehyde. That is the statement, and then you need to write this one, that is the reaction. Okay, so this is your 2-marker equation and statement, this is 2-marker equation and statement. Next question, among formic acid and acetic acid, which is weaker acid and why? So acetic acid is weaker acid, okay, and why? Because you can write because the conjugate base of acetic acid is less stable due to the plus I effect of methyl group, right? See what I am saying, this CH3COO minus, right? This is the conjugate base. Now this conjugate base should be more stable, but here this CH3 group is doing what? It is pushing the electrons, plus I effect, and it is destabilizing this conjugate base. So that is why this is less stable or less acidic than your acetic acid. Okay. Next question, explain the preparation of carboxylic acid from Grignard reagent, write the general equation. So we'll just write general equation for this one. Preparation of carboxylic acid from Grignard reagent. So if you have any RMgX and you treat it with CO2, what will happen? Minus plus, this R minus will attack here, this one will shift here. So what will I get? RCOH double bond O, right? So that is what is you can write in the statement. First you need to write what you need to write here, that Grignard reagent reacts with carbon dioxide, okay, to give you carboxylic acid. Okay, next explain esterification reaction with an example. So here also you need to write what alcohols, okay, reacts with carboxylic acid, okay, to give esters, and this bond breaks like this. You need to show minus water in presence of acidic medium to give you RO, C double bond O, R dash. Clear? Next, what is the effect of, so here statement and reaction, 2 marks. Next, what is the effect of electron withdrawing group? Electron withdrawing group increases the acidity of carboxylic acid. Okay, so 2 plus 2 plus 1. Done. Next question. So next question, this is part A, where you need to write the name of the reactions. Okay, H2 palladium barium sulfate. This is which name reaction? This is Rosenmond reaction. Right, Rosenmond reaction. Next one I'll write here, it will be more clearly visible. First one I think all of you can guess, this is Rosenmond reaction. Okay, next part, question number B, CrO2 Cl2 H3O plus. So this is your Itard reaction, right? Next COHCl, this is Gattermann-Koch reaction. Okay, so Gattermann-Koch reaction. Okay, so name 3 name reactions you have written. Next, among 4-nitrobenzoic acid and 4-methoxybenzoic acid, which is more acidic, give reason. So you have 4-nitrobenzoic acid. Okay, so 1 second. Yeah, so you have 4-nitrobenzoic acid, okay, and 4-methoxybenzoic acid. Here 4-methoxybenzoic acid. Clear? Which is more acidic? So obviously 4-nitrobenzoic acid is more acidic. That is the first thing. Now give reason. So you have to write here NO2 group. NO2 is a electron withdrawing group and stabilizes the conjugate base. Okay, you should write the full word here. Okay, and stabilizes the conjugate base. Therefore, you can write down here, whereas OCH3 is electron donating group, okay, and destabilizes the conjugate base. So nitrobenzoic acid is more acidic. Okay, this is the explanation. You can see here nitro group is what? Electron withdrawing group. OCH3 group is what? Electron donating group, and we know that electron withdrawing group increases the acidity and electron donating group decreases the acidity, right? Okay, next question, explain Rosenmond reaction with an example. So okay, so first of all you can write down acid chlorides, right? Acid chlorides react in presence of H2 palladium barium sulfate to give aldehydes. Okay, that's the first thing. Next, how does propanol reacts with hydrazine give the equation? So this is 2 marks. Okay, you need to also write the equation, right? So we can take any benzyl chloride, we can take, okay, then react it with hydrogen, palladium and barium sulfate to give you what? We have this one, C double bond O H. Okay, that is done. Next, this carries 2 marks. Next, part B. Part B is what? How does propanol react with hydrazine? So we have propanol here and we have hydrazine. Okay, so reaction what will happen? This one will go and CH3 CCH3, okay, then double bond N NH2. Okay, this is the first thing. Give equation. So you need to write here that propanol reacts with hydrazine by dehydration to give you hydrazone. The product formed is hydrazone. Then you have to write the equation. Name the oxidizing agent in the Ettard reaction, that is CrO2 Cl2. Okay, that is the third part. Clear? Okay, now let us go to the next question. Again, you have one complete the following reactions question is there. So let us see the first one. This is what? Clemmensen reduction. So A will be CH3 CH2 CH3. Okay, next 2 will be what? CONH2 H3O plus, right? What does this one will do? This one will convert these two. We will get, there will be dehydration of water. Okay, now let us see the second one. We have CONH2 with H3O plus. So this one will get converted to, obviously, to benzoic acid. Okay, next NaOHCO is what? This is decarboxylation agent. So it will remove carbon dioxide and we will get here methane, CH4. Okay, clear? Done this one, 3 reactions. Next one, how benzene is converted into benzaldehyde by Gattermann-Koch reaction. Okay, so if you remember, I have given the definition here, write its equation. So here also how to write the definition. See, when benzene or its derivative is treated with carbon monoxide and hydrogen chloride in presence of anhydrous AlCl3, okay, or cuprous. So this, if you do not remember, that is also fine. You can write down when benzene reacts with carbon monoxide and HCl in presence of aluminium chloride, anhydrous aluminium chloride, it gives benzaldehyde or substituted benzaldehyde. Okay, so now if you want to write the reaction, we have what we have here. First of all, we need to have benzene, right? So CH3, then if you have reacts with you can just take benzene or its derivative is given, so I will take benzene, okay, and then I will react it with COHCl in presence of anhydrous AlCl3 to give you CHO. Okay, so that is the reaction. This is the definition, carries 2 marks. Okay, clear? So next question, aldehydes are less reactive than ketones, give reason. So this is a direct question from your NCERT. Here you need to write 2 reactions. The 2 reasons you can write down. First is your first one is steric effect, right? Ketones are more hindered, and the second one is electronic effect. Okay, you need to define them. Okay, electronic effect. So this statement and the definition here, statement and the definition carries 3 marks. Okay, to the names and the definition, the explanation you need to write. What you have to write in steric effect? Due to in the ketones there are 2 bulky groups attached, so the nucleophile finds it difficult to attack on the carbonyl carbon. Next, in electronic effect, what you need to write? The carbonyl carbon in the ketones is less electrophilic due to the adjacent groups present. Okay, that is what you need to define. Okay, so write the explanation. Okay, now how is benzamide obtained from benzoic acid? So we need to get benzamide from benzoic acid. So we have benzoic acid and we want benzamide. Okay, so first thing is treatment with ammonia. So what will happen? One H plus will come here, OH. So there is a acid base reaction. So we will get like this, C double bond O and then O minus NH4 plus. Okay, after that what happens? There is dehydration. Okay, there will be dehydration, water will be removed and we will get CONH2. Okay, that is the 2 marker question here. Okay, so next question, I think this one we have already discussed, right? Yeah, okay. So students, these were some of the most important questions from aldehydes and ketones. So 5 marker questions, definitely you can write some answers. Okay, so please prepare all the name reactions present in this chapter, all the mechanisms, ammonia derivative, and there are a lot of name reactions in this chapter and some reasoning questions like why aldehydes are more reactive and why phenoxide ions are less stable. So such some reasoning questions also you can expect. So please prepare them. If you have any doubt in any concept, do not forget to comment down. I'll definitely address it. Okay. Thank you for watching and all the very best for your midterm examinations. So any other request, any other help you needed, please do comment down. I'll definitely take care of it. Okay. So if you have found this video helpful, please do not forget to subscribe the channel.